I'll be talking about new features in 10.0 and 10.1. So let's just get started before it breaks. So just, talk a little bit about the user interface. You guys have been using it now. It's not so new and different, but we think a really solid platform for future growth capabilities, long-term .NET framework. So we're really looking at visioning into the future. For those that have been using, or for any old user on the old user interface, it was written in VB6. VB6 has not been updated. Not a single DLL of VB6 been updated since 1998. I expect at some point in time, Microsoft is going to drop support for that, and it's just going to go away. People will no longer be able to even run it on their machines, which is one of the big drivers, of course, was to switch to the new user interface. It's in C#, .NET framework, very current, modern, and very strongly supported language for the future. So we're very happy about that. We have literally been working on this for about 7 years. Obviously, early on, it was more just strategy and planning and stuff, but we have been heavily involved in the development of this with the development team in Hanoi, and me here, working on this, on the coding and development of this tool. So we were very excited about when we released it, a few months ago. But we released a 10.1 or 10.0 in kind of a beta version, and it was a little buggy, but 10.1's, as you guys hopefully have been finding, is pretty stable. Always, you always find little things here and there, but should be a very stable platform for the future. And as you guys now know, you can bring up all kinds of windows, and in this particular case here, looking at Lake Washington, you can simultaneously view different views and then animate them or step through, time series, and everything gets updated. If this is a temporally based window, these will just be synced right up with whatever it is that you're looking at. So yeah, we think it's a great user interface. But user interface by itself, of course, is only part of the story. You need to have a lot of capabilities and robust features in order to make this tool really useful. And one of the things we've now done is add the capability to directly within EEMS directly go out and identify a data source such as bathymetry, winds, tides. Different data sets can be accessed online and pre-configured automatically for your EFDC model. So you've got this online download data here. It's also, if you've seen it at a couple other places in different forms, depending upon what you're working with, there's access to online data. Of course, it's the user's responsibility to make sure that A, it's accurate and appropriate for your application, and B, the spatial and temporal resolution of your online data is appropriate. So, it's incumbent upon the user to apply that, their expertise and knowledge on, is it appropriate? But we have links here to a number of different online sources. Viewing multiple models. This says models. These are not two separate models right now. They're actually two separate views, but you can view, and I don't know if you guys have done that yet, where you can load up different models and can compare them. But this particular example here is really a 2D plan view of the Lower St. John's Waterway. Jacksonville is located, where are we at here? Right around in here. And we were looking at, they were doing Corps doing a dredging project in the harbor, and is doing a dredging project, and we were looking at the salinity intrusion as a result of the dredging. But you can see in the longitudinal profile, starting up here, upper end of the lower St. John's, kind of going down the center line to out into the mouth. This is this particular profile only extends out to about location about right here. You can see in river kilometer distance downstream. I don't know if you've played around with it, but you have these, the units are configurable. You right mouse click on the axis and you can select kilometers, miles, meters, whatever it is that you want. On your x-axis, on your y-axis, of course, it's very dependent upon the plot that you're looking at. It's context sensitive, so it knows if you're plotting time series or if it knows if you're plotting a longitudinal profile, etc. So you have a lot of access to different units for your visualizations. And then, of course, you've seen animations. If you turn on an animation, you would watch the salinity move in and out during as forced by your tidal conditions. And then here in the longitudinal profile, you would just see the salinity wedge as it moves in and out of the system. Nested configuration. This is a decoupled one-way nesting process where we now have the ability to automatically extract information from, say, a larger scale, coarser grid model to build the appropriate boundary conditions for a nearer field, higher resolution model. For computational reasons, you don't want to have the entire domain. See here in this particular example, we've got the white grid as a coarser grid overlaid on the map here, and then the green grid is a higher resolution, say, focus study area where you want to look at some process that's going on in that area. With these two different grids, you load them both in to EE. EE recognizes that this is a correlation of, this is a boundary here and there's a boundary here, and we'll extract all the appropriate boundary conditions, water levels, concentrations, what are the other major things? Well, flows and concentrations. Well, yeah, for whatever, all the constituents that you're currently simulating will be extracted from the large scale model and set up for your small scale model. And vertical layering is handled. It brings it in on a per layer basis. So if you've got stratification, that it's accounted for. So quite a robust tool accessed here under the model nesting utility here. We had this capability in EE8 and before, but just wanted to mention here the create warm start. Just a real quick clarification about the three different kinds of model initialization schemes. Cold start, that's essentially where you, the user, has fully defined everything for all the initial conditions to start up the model. That's what we call it, as a cold start. A hot start is when you've turned on in EFDC a restarting model capability. So at every user-defined interval, EFDC will write out all the variables necessary to start a new model up right at that same point, and then run it forward from that point on. But all your hydrodynamics, your momentum, your velocity field, everything is stored in the restart file, so you can just kind of start right there and then launch forward. Really helpful if it crashes, but also for a lot of different applications, we use the restart file, which is considered a hot start. Warm start's kind of in between. Warm start is, let's say you have a 2-year run, and 6 months into the run, you want to change some parameter. You want to look at something, some other process or something different. You can use EE, jump to that time, and write out a restart file, which saves all your water levels and all your 2-dimensional or 3-dimensional field parameters for everything from water column, sediment bed. Yeah, I mean, so you've got a complete initial condition, except for all your momentum and hydrodynamic terms. They start off all at 0. So your velocity at that particular time that you're starting off would not necessarily mimic the actual conditions in the system at that time exactly, but usually, within a couple of tidal cycles, you're going to be right back into having something that's essentially the same values as what you were getting as if you had a warm start. But there's some slight differences. But this is a nice capability, and we're using it right now on a couple of projects. So that's 10.0. What you now have in 10.1 right now are some capabilities here in temporally, what we call temporally varying fields. So these are 2-dimensional time varying fields. Things that you can change include bathymetry. So if you have, say, a dredging operation or a filling operation, and you want to, say, run the model over a 2-year period, and in the middle of that, there's a dredge. You can use this capability with bathymetry, just run the model continuously, but at the time of the dredge, you would change the bathymetry from the pre-dredge condition to the post-dredge condition, and EFTC will just do a continuous simulation accounting for the change in bathymetry. That said, things like how fast you bring in you can't just instantaneously change bathymetry in the model. The model will crash for sure. So there's different ways to interpolate temporally inside the you can linear interpolate between 2 different snapshots in the bathymetry file, or you can have a couple of intermediate steps during the bathymetry input file so that it can transition more rationally, because obviously you don't dredge in 1 day anyway, or in 1 second. So this is a powerful tool for looking at those kinds of analysis. Also, though, we've got wind and pressure fields. Traditionally, EFDC, you could have multiple wind stations, but they were fixed locations. So if you had a station, well, let's just use this example here. This is the Florida Bay, and you might have, say, here in Miami, you've got a wind station here, and then say Tampa's way up there, but Marco Island or something, you've got some station here, and so you could have 2 different wind fields. But out here, it's a constant weighting. You would just maybe 60% of the wind comes from this station, 60% comes from this station. But that doesn't work for hurricanes, because what's happening here and here doesn't affect, or maybe be completely different when what's happening down here. So we now have the ability to bring in 2-dimensional wind fields and pressure fields and actually simulate the effects of hurricanes. So let me just do something here. I didn't get time to bring it into the animation or into the presentation here. Which button? Just bring it up. There we go. Day 3 materials. See if it just show you here as an example. Didn't have the player what? Connecting. Why is it needing to be on the internet just to... Oh, well, maybe this isn't going to work. Because it's trying to find the internet for some reason or other on this machine, which I don't know why. Makes no sense to me. Oh, well, never mind. We'll go back to... Where is the mouse? Come on back. Trying to get it back, the PowerPoint back up. I don't know why Windows player didn't play, but it didn't. Anyways, trust me, you can simulate hurricanes with this, with the wind field capability. So nice feature for a number of different reasons. We're also using it as another example where we have a really high resolution groundwater model that has temporally varying fluxes of water into the domain, and we're using this feature to bring in the groundwater flux, which is a separate series at every single node. So quite a, if you were trying to do it with time series, it would just be really difficult to manage. All right, you've seen this with 10.1. We now have the ability to have any number of user-defined die classes, and with settling, decay, growth, temperature dependent or not. And then one of those die classes, of course, can be the age of water, which we use a lot for mixing. But in this particular case, this is Lake Okeechobee. We have a wind field here. The black lines, I don't know if you've used masks, but these are thin barriers that prevent flow from crossing across a mask interface here. So this area here is kind of isolated except for a few holes. Anyways, you take this system, apply a wind, there's vegetation in here, but what we were wanting to understand is kind of where's the different water sources coming from. So we have an applied die class here at Fish Eating Creek and an applied die class at Kissimmee River coming in up here. And then you can see the relative patterns of mixing on the in the system. Now, it's a little tricky when you're, I don't know if you've noticed or not, but when you're visualizing a two-dimensional view, you can only see one layer at a time, unless it's a vector, it's an overlay layer. So like the velocities, that's a separate layer, and then the die is a separate layer. But notice there's two die classes here. We have the ability to put a low end cutoff so that any concentrations below 0.1 are transparent. So that's how you can see two die concentrations simultaneously on the same plot, because typically, at least in this scenario, where you have high concentration or high source water in one area, high source water in another, and you use a low end cutoff so you can see both at the same time. Kind of handy. Yeah, we made a lot of updates to the SEDSL-J routine to make it more robust and capable. Not going to get into the details, but we also coupled the toxic submodel to the SEDSL-J, including bed load, so you can have bed load movement of your toxics using the SEDSL-J routine. Yep, it's probably enough on that. Let's just go to the next. Nope, it was trying to. So let's just talk about this. Now, here, there's a lot of cases where, this is the vertical grid here is, by layer, and with the new Sigma Z capability we added back with 8.0, you now have the ability to have differing number of layers everywhere in the domain. So, one area can have 55. In this case, this model has 55 layers, 1 meter thick layer throughout the system, except for, in the deep area, but over here in the shallows, we step up, so it may only be 10 layers in one area and 55 layers in another, etc. However, once a layer, traditionally, with all, old versions of EFTC prior to 10.1, all the flow across all the layers were all connected at 100% of the time, unless the cell went dry or wet. Then it could vary as to whether or not the cells were connected from one cell to another. But there are many cases where you actually only want partially blocked vertical layering. In this case, what we were looking at is the floating bridge, the 520 floating bridge in Lake Washington. It's about 3 meters, about 3 or 4 meters deep. But it only affects the surface. It doesn't affect, at depth. So if you're going to appropriately handle transport, especially anything that's floating, or really with a stratified system, any kind of, horizontal transport will be particularly impacted by a floating bridge. So we built this capability where you can partially block a interface between cells, either from the bottom, like a sill. If you had some sill that prevented water, movement between two different areas, or from the top, or you can actually put them anywhere in the middle of the domain if you want. But this particular example here is shown as a floating bridge. Whoops. So just from a demonstration perspective, it does work better, I think, when we put them inside PowerPoint, hopefully. Yeah, there we go. So what we did is we defined 4 different groups that just to demonstrate this capability. We had a group that we called north and a group south, and then we seeded these particles at 2 different depths, and we did not allow the particles to change depth. If this is a full 3D Lagrangian transport model, there could be some particles diving underneath. The model is fully 3D, but this example, we fixed the migration of the particles by their initial seeding elevation. So what that allows you to see here as the winds are blowing, and well, let me explain the color, the background color. The colors that you see here are wave height based on the wind wave model. And one of the things that are important, of course, what waves are particularly impacted by surface structures. And you can see as the wind changes direction, it's the floating bridge impact on wave propagation through the system. So it handles both wave conditions as well as just the hydrodynamics and particle tracking. So yeah, as the particles move around, the ones that are shallow, which are the north and south, the orange and yellow particles, they basically just get trapped by the bridge, can't pass, north and south of the bridge. Whereas the deeper particles, they just pass right underneath it. So nice capability. This works with density. Go on our website. I was going to show you a video that I have here, but since videos don't work, I won't show it to you. But we did, using the 2D salt tank example that's on our website, we put some baffles in it, and you can see the effect of a fully density-driven flow with the baffles, and it's a nice little visualization of that condition. So things coming in 10.2. The biggest, the thing that I'm, most both excited about and, and hopeful and about, and we've been working hard on this, is parallel processing with MPI to speed up our runs. Traditionally, with OMP, which we've had for years, where the OpenMP technology has been implemented in EFDC, as you throw more threads at it, it speeds up, but pretty much you never speed up past about a factor of 4. That's about the maximum speed up you can get on, no matter how many threads you throw at it, because it's shared memory, and very quickly you start getting into just, memory bottlenecks and things just slow down. Still 4 times faster. If you've got a 100-hour run, 4 times faster, you get essentially done in a day. That's a big productivity gain. So OMP has been a real powerful tool for many years, and we continue to have it in the MPI. We're actually using mixed mode capability, so we have MPI and OMP. Very powerful. That said, it takes a little bit of trial and error to find the optimal number of what we call nodes or processors with the number of threads. So there's sometimes it's better to have a few more threads and less processes. Sometimes it's better to go all processes and less threads. And that just takes experience. What we're trying to do is build guidance for the user, to give them some basic starting point of where they should probably start with their, defining their application. This basically deals with, what you're doing is we're using domain decomposition, where we break the spatial domain into these discrete pieces, and then each one is solved individually, and then we couple them together at each time step across something known as a ghost cell process. But it's really important that what you're trying to do is balance work. And work is not the same as the number of cells. So it's a little bit of a tricky process to kind of get the optimal case, but in any case, it's always faster. So I'll say, unless you just really screw up the settings. So very powerful new tool. You can probably run models with millions of cells if you throw enough nodes at it, and it'll run in reasonable amounts of time. We have we're adding zooplankton, but we have added the any number of algal classes now. So you can have 1 or 20 different algal classes, and then we can have any from 1 to 20 zooplankton classes if you want. So that's kind of where we're going with the zooplankton capability. For a company in South Korea, they wanted to simulate, I think it's oysters, but I'm not exactly sure which shellfish that they were actually growing, but they wanted to simulate a condition for a shellfish farm. And so we built in, with some of their guidance and direction, we've built in a floating shellfish farm feature. So you can put in like shellfish racks floating in the water column, and you got the full interaction with the water quality so you both get nutrient release as well as nutrient uptake. You're simulating the growth of the shellfish. All that is in the new shellfish farm capability. And kind of within that, we've expanded the shellfish larva simulation capability. We are adding a more GIS capability, if you will, and being able to handle 2 things. Number 1 is projection, coordinate projections. If you notice, EE allows you to use any coordinate projection you want, but it doesn't have any conversion. You have to do all your conversions outside of EE, bring them in so that everything is consistent within your simulation, your model domain, so that things will work with 10.2. We'll have coordinate projection capability, so we can bring in, as long as it's got like a projection file from ArcInfo or ArcView, something like that, then it'll read it in properly, do the coordinate conversions, and bring it in into your model domain. And then online background images, so you don't have to create your georeferenced images beforehand. You can go onto an online resource and bring those in. Yeah, and we're adding a warm. Apparently, I thought we had this, but apparently we don't. When we create the warm start file, we don't create the input files necessary for the particle tracking. So it's almost more of a bug than a feature, but it's a bug fix that will be addressed in 10.2. And then we've got some of these others, 2D and 3D particle tracking. We already have visualization of this. This is just a new fancier way to display the same information. And yeah, just some of our GIS support linking to MIF and MID files as well as shape files and others, which we currently do at some level. And then we're linking more to some of these more standardized data formats, just to allow EE is a great tool, does a lot of things, but it doesn't do everything. Every project has, or many projects have, specialized needs for their project to do certain analyses. And, we have our linkage files that are there, which are powerful for doing a lot of things, but, you have to write, we provide tools to allow you to access those binary files and pull out any data you want to do with it. But people already have tools that have been built for, NetCDF and some of these other standardized data formats. So we're linking, being able to convert our output to some of these formats just to ease of the user to do some of these additional analyses. Yeah, I mean, we're pretty excited about this release of 10.2. When does it come out? That's the question. This is what we'll do, just so you kind of know our strategy is I try to target a release roughly about every 6 months. So this would be a 10.2. We released 10.1 in October. Mid-October, we're kind of shooting for April or May. The idea is we're going to release something in April or May, and it'll be a 10.2. It'll definitely include these components, optionally include these. We'll get as far as we can, and then we're going to cut it off, release 10.2, and then we'll keep working on these, and these will be 10.3. So about every 6 months, we want to issue a new incremental update to EEMS. But if there's a bug fix, those we post as we get to them. So, if we get bugs, notifications, and we fix EE, at not less than a month after we have fixed it, is it posted on the website so you can get it. If it's a critical project-driven bug, we'll try to get to it as quickly as we can and maybe just send you a direct link so you can download the tool, directly. It may not be posted on the website, but you can have access to it. Bugs are fixed for free because it's a bug, not a new feature. If you need a new feature for an application that's not here, then we just work something out, like we're working with the Navy on prop wash. So we're actually doing that for Exxon, so it's Exxon and the Navy helping, DSI and the Navy helping Exxon end up with this tool, and Exxon's paying for it. But anyways, the idea is, we can add features, but generally those require special contracts, tasks with us. Now, the prop wash feature will probably be released in 10.3 because it's going to be part of the commercial product. And with that, I think that I'm essentially wrapped up on the kind of new features. Any questions? Any requests?